Rare earth minerals comprise 17 metallic elements, including lanthanides, scandium, and yttrium. Despite their name, they are not rare, but difficult to extract and refine. These elements are essential for modern technology, including smartphones, computers and batteries, medical imaging, defense systems, radar, lasers, and fighter jets are vitally important for developed countries. The military uses rare earth in fighter jets, missile guidance systems, radar, stealth technology, and satellites. Rare earth is essential in hospitals for MRI machines, X-ray imaging and radiation therapy, and the energy infrastructure, such as wind turbines, electric grids, and high-performance batteries, is heavily dependent on these minerals. This vital sector can be vulnerable to oversupply, which can temporarily lower prices if emergency demand spikes, e.g. geopolitical conflicts or supply chain disruptions. If production slows due to low profitability, supply may not meet urgent demand. This could cause costs to skyrocket if nations rush to secure supplies for defense or energy purposes. Another major factor that should not be overlooked is supply chain instability. The dependence on China for rare earth exports makes global industries vulnerable to strict control and restrictions. These are the nations leading the world in rare earth reserves. China, 44 million metric ton, largest producer. Vietnam, 22 million metric ton. Brazil, 21 million metric tons. Russia, 10 million metric tons. India, 6.9 million metric tons. Australia, 5.7 million metric tons. United States, 1.8 million metric tons. Greenland, 1.5 million metric tons. Ukraine's reserves in rare earth elements is estimated to be about $16 trillion. Rare earth mineral mining is a time-consuming process that can be complex and take months to years in refining and extraction. The process includes extracting ores containing rare earth elements, crushing and breaking down ore into smaller particles, chemical separation using acids or solvents to isolate rare elements, then refining and purifying the elements for industrial use. Processing rare earth minerals can take months to years, depending on the complexity of extraction and refining. Because of rare earth's properties, finding an alternative mineral that could be substituted seems to be a long way off. Scientists are exploring substitutes to reduce reliance on rare earths. Here are some of the prospective elements. Ceramic magnets, ferrite magnets, are used in motors. They are cheaper but weaker than rare earth magnets. Graphene-based technologies have high conductivity and have the potential to be a competitive replacement for rare earths. Aluminum alloys are lightweight and strong and is an alternative for structural applications. Iron nitride magnets have efficient magnetic properties and are a potential substitute for neodymium magnets. China dominates rare earth production, controlling over 70% of global mining and 90% of processing. Because of security concerns and the monopoly that China holds, including restrictions on exports, which impacts industries worldwide. Many nations have been forced to take drastic steps to diversify supply chains. Australia, the US, and Europe are investing heavily in rare earth mining and refining to offset global security risks. If modern technologies continue to rely so heavily on rare earth minerals for the manufacturing of chips and semiconductors, without alternatives, such dependence on China as the major supplier could be a major risk for the industry. However, refining and processing remain a complex part of the equation and very time-consuming, making long-term planning essential. Thanks for watching. Don't forget to subscribe to this channel for more global insights.